Creating surfaces from a DEM file in Civil 3D, created by Ahmed Dmour. Welcome to this lesson in creating and managing surfaces in Civil 3D. Surfaces are the foundation of any civil engineering project. In this lesson, we will cover two key workflows. One, how to download digital elevation model DEM from USGS EarthExplorer. Two, how to import DEM files into Civil 3D to create grid surfaces for engineering analysis. By the end of this lesson, you will understand the difference between TIN and DEM surfaces and when to use each of your projects. Downloading DEM data from USGS EarthExplorer. Let's begin by downloading DEM data. Open your browser and go to earthexplorer.usgs.gov. Then log in with your USGS account here or created one for free if you don't have it yet. Next, select your area for interest. You can search by place name or coordinate or draw a polygon directly on the map around your project site. We can go to Portugal, for example, here. Enter search criteria. You can enter feature name here or choose it from state. Here you can select polygon as shown for this area. You can clear coordinates. You can use map as shown like this, clear, and you can choose circle at center and 0.2 for radius to create a circle, clear, select for example this area and use map for this area. Then go down to the bottom of the screen. Here in date range, we can also specify the date range from, for example, 2023 and to 2025. Also can specify the cloud cover from here. Cloud cover range from 0 to 100%. For example, from 0 to 25%. Then click in datasets. Then go to datasets. Down and choose digital elevation. Then SRTM, SRTM1 R2. Then click in result. Once the result appears, download the DEM in GeoTIFF format. For example, this image as shown. These are the results that appear next to each satellite image. For example, this image entity ID showing information about it, the satellite that captured it, SRTM1, and coordinate N40W, and the date of publication here, publication date in 2014, the image resolution and coordinates here. There are several options below each image. The first is show footprint as shown. Since this option allows us to specify the location of the satellite image On the map, we notice that this image covers a small part of the specified location, or the one we want. So, we will choose the second image here, as shown, and you can click here to show browse overlay, turn off show footprint, and here, and you can download this image from download option. When downloading digital elevation model from USGS EarthExplorer, you will find different file formats and resolution available, such as GeoTIFF and DTED PIL format. GeoTIFF, the most common and recommended format. A raster file that stores elevation values save as a TIFF image with the georeferencing information. Works directly in Civil 3D most JS software. Keeps projection and coordinate system data embedded, easy to share and visualize. Best choice if you are working in Civil 3D or ArcGIS. Bill, band interleaved by line, an older raster format where data is split into several files. And this format, DTED, a format originally developed by the US Department of Defense, widely used in military and navigation. And you can show arc-second resolution here, arc-second resolution levels SRTM1 versus SRTM3. This is not a format, but a measure of resolution. SRTM1 as 1 arc-second equal 30-meter resolution. High accuracy recommended for civil engineer, road design, and hydrology. SRTM3 3 arc-second equal 90-meter resolution. Lower accuracy good for regional planning, general mapping. Arc-second refers to the unit of angular measurement in geographic coordinates. Choose Download GeoTIFF, then go to Folder, open it. This is image. Then return to Civil 3D, creating surface from the DEM. Then go to Setting and right-click in Drawing, Edit Drawing Setting, then add Projection, choose Portugal, then choose, for example, UTM Zone 29 North, then OK, then return to Prospector, right-click in Surface, create surface from DEM, then choose this file as GeoTIFF format, open it, waiting to read points and create the surface. After finish, open surface, expand it, then grid from DEM, zoom to the surface as shown. This is the map, and you can zoom in, and you can add boundaries to the surface in this area. Go to definition, then boundaries, add, name it as area, type outer, then select object, wait to generate the surface for this area, just for this area. As shown. Thank you for watching. See you in next lesson.